All right, guys, welcome to this section. In the course of today's class, I'll be teaching us on a very important aspect in chemistry. And, after explaining this concept, we'll solve questions. So you guys should get ready. If you are online, do well to signify so we can start right away. If you are online, do well to signify so we can start right away. So let me know, guys, in the comments. If you are online, let me know. And also comment down where you are watching from. And also do well to share with your friends. And also ensure you like the video so others have opportunity to, see the video and watch. So let's see how it goes. We are starting with a very key aspect today in chemistry. And what aspect should I treat? All right, okay, I've seen it. I think I should start with this aspect so we can progress. All right, guys, ensure you like the video. Don't just watch without liking, because we are going to start in a few minutes. Don't just watch without liking, guys. Don't just watch without liking. All right, very good. Comment down where you are watching from. Comment down where you are watching from. All right, good day to you all. You are welcome to this live section where I'll be teaching chemistry. And let's start. This is the topic I'll be treating in the course of this section. And it's called. Alright, let me write first so you tell me what it is. The topic is, you already know what you've heard this before, right? The topic is this and something else. And what I'm about writing next. So guys, ensure you pay attention to the explanation of today's class and also the way we'll be solving practice questions. So get ready, guys. So you can see what we'll be treating in the course of this live section. It is simply called isotopy and relative atomic mass calculations. Isotopy and relative atomic mass calculations. Very good. Guys, ensure you like the video and also share with your friends. So first of all, before we start, we have to know what we are talking about. You can see this topic is divided into two aspects. The first aspect is understanding properly what this terminology means, called isotopy, and the other aspect is for us to be able to learn how to solve questions under this other aspect called relative atomic mass. You understand? So you just pay attention. So the first question we ask ourselves, what is isotopy? That's the first question we ask ourselves. What is this terminology called isotopy? Alright, I break it down. Isotopy, before we even start, whenever in science you see the word iso, in science you just see any word start with iso. Iso simply means this. Iso simply means the same. Put that in your mind. Iso simply means what? The same. Now, what is now isotopy? What is now isotopy? Now, let's go. And what's isotopy now? This is, alright, I'll start like this. What's isotopy? This is a phenomenon. Whereby, I will not start. This is a phenomenon, it's not just about defining, it's about understanding. This is a phenomenon whereby atoms, what did I say? Whereby atoms, you can see there's S attached to the atom. So whereby atoms of same elements, I'm going to explain. Atom of same elements. So you can see where this same is now coming from. You can see now iso means the same. So, let's define. So atoms of same elements is a phenomenon whereby atoms of same elements have same atomic number. There's something called atomic number which I'm going to talk about also. Same atomic number, because any terminology I see in the course of this class, I'm going to explain it. Any terminology I know that if you might have difficulties understanding, I'm going to explain this too. So it's a phenomenon whereby atoms of same element have same atomic number, but different mass number. Different mass number. So let me explain. As earlier said, it's not just about knowing the definition. You have to know what this topic is all about. You have to know exactly what I am defining, and I'll be explaining it right away. So I've defined, let me explain. I've defined, wow, thank you so much. Thank you so much. Thank you so much, KX, for the gifts. Wow, I really appreciate this. Meanwhile, guys, ensure you like and also share. KX Edit, thank you so much for the gifts. I appreciate. So for others, do well to respond, do well to engage, do well to share the live with your friends. KX, thank you so much. So now, let me explain. Isotopy is a phenomenon whereby atoms of same element. First of all, the first word that I'm seeing here is atom. So we have to know what atom simply means. And another word I can see here is elements. Because you know what same means. So atom, element, what do these two things talk about? So let me explain it in a very easy way. So first of all, write elements here. And also I'll put atom down. You can see what I'm doing. You just pay attention. I believe in chemistry you are familiar with very many elements, like lots of hydrogen, helium, lithium, beryllium, boron, as the case may be. So let's just use hydrogen as a case study. This is hydrogen. I believe you know hydrogen is an element. So now, how can we now relate atom to elements? Let me explain. Very easy. What's an atom in an element? How does these two guys relate? Let's go over to biology. I believe you are aware that the basic unit of life, you can see me now, you can see yourself. The basic unit of you in biology, they call it cell. Before you came into existence, you started with cell. That's in biology. But in chemistry, for any element to be created or discovered, it must start for being an atom. So meaning that for any element to be discovered, the element should start from an atom. So what's an atom? It's simply the smallest or the basic unit of any element. Do you understand? That means all elements in chemistry have their various atomic forms. Are you following me? So but properly on defining atom, I'll simply say that an atom is the basic structure. For atom now, atom is like the smallest unit of an element that can take part in a chemical reaction. That's what an atom is. It is the smallest unit of an element that can take part in a chemical reaction. So this atom is like the smallest part of these elements. So I'm using hydrogen as a case study. What's the smallest unit of hydrogen? Atom. Do you understand? Helium, what's the smallest unit to an atom? So all elements have their smallest unit, which is atom. So basically now, for you to understand what I just mean, atom of every element, for you to signify atom of every element, you just write the symbol. You just write the symbol. I believe you know the hydrogen symbol is H. Hope you are aware about that. Because, listen, this thing I just wrote is different from this one, H2. This one I just wrote and you are seeing H should be pronounced specifically as hydrogen atom. It should be pronounced specifically because you have to, these are the rudiments in chemistry. What I just wrote now, H is hydrogen atom, but this one you are seeing is different from this thing. Oh, this one now is a molecule. You know, I'm not talking about this topic right now, but you know, because what I want to explain now is not making me, you know, teaching so many concepts. So this now is a molecule. Why? It is made up of two atoms connecting together. You can see it's two hydrogen that came together to form H2. So you must understand here that when for a molecule to be formed, it will be formed from at least two atoms of an element. You understand? So this is one hydrogen atom, this is another hydrogen atom connecting together to form H2. Then H2 will be called hydrogen molecule. Do you understand? So this one now should be called what? Hydrogen what? Molecule. Do you understand? Because we are not done. Hydrogen what? Molecule. So I can also use another element like oxygen. Everybody, you are familiar with the symbol of oxygen. Oxygen is symbolized as O. Now, I believe you know that me erasing O, how will I pronounce it correctly? I will simply say it's called oxygen atom. But let's say, for instance, we have two oxygen coming together. What are we to form? O2. Then what will I call this one? Hydrogen. Oh my, what am I saying? What will I call this one? Oxygen molecule. Do you understand? Because it's a molecule now. We cannot, it's not just two elements that form molecule. Multiple elements can form molecule. Let's say 1 million of a particular element can come together to form a molecule. Still, so everybody listen. We can have 3 oxygen atoms coming together, then we'll form something like O3. So this is still oxygen molecule. This is still oxygen molecule. But this one that is down, now listen, this one that is up, they call it dioxygen. Di means two, so we have two oxygen, dioxygen. This one is trioxygen. Both of them are oxygen molecule. Do you understand? They are oxygen molecule. But this one that is down, which is O3, is also regarded to be called ozone. This one that is down, which is O3, is called what? Ozone, which basically forms the ozone layer that protects us from ultraviolet ray from the sun. Do you understand? So that's the point. Though we've not started what we want to do right now. You understand? Because I have to teach you guys the rudiment. I have to teach you guys the rudiment. Alright. So that is for that. Guys, ensure you engage. Share with your friends. Share with your friends. Very, very important. Like and also share the video with your friends. So now that's the rudiment. So class, listen. Where is the duster? Alright. Guys, ensure you like. Don't just watch without liking. So that's the difference between an atom, a molecule, and an element. Both of them are different. So everybody just hold on. I want to wipe again. I'm about wiping. Because before I progress, I'll still tell us some stuffs. Before I progress, I'm still going to tell us some stuffs. Everybody just relax. So now moving further, guys, what do we understand next? We've understood the difference between an atom and a molecule. You understand? Because my definition says isotopy is a phenomenon whereby atoms of same elements. Atoms of what? Same element have same atomic number but different mass numbers. Now, this atom we are looking at can be represented in various ways. Atoms can be represented in what? Various ways. So I can represent an atom by drawing circles. Listen, I can represent an atom by drawing circles. This is like the diagrammatic way to represent an atom. Now you just listen. Let me draw an atom for you. Atom of any element at all in chemistry. Now you can see what I am drawing. Now let me explain what I just drew. So this I just drew, I can also call it an atom Do you understand? So most importantly is for you to understand the breakdown, the component of an atom. You should understand here that atoms in chemistry, they are made up of three important subatomic particles. What did I say? Atoms in chemistry, they are made up of three important subatomic particles, which I regard to be called pen. What are these subatomic particles? So this atom in general, inside this atom, there are three important subatomic. Subatomic means that they are found inside atom. So that's what we call them, subatomic. Do you understand? The word sub means that you are found inside something like, in your note, when you're copying your notes now, we have heading, we have this, the heading of the topic. So anything I write below it is like subheading. So this one is subatomic. What is that subatomic pen of an atom? What are they? The P here means proton. The E here means electron. Whereby the N here means neutron. Do you understand? The P means proton. The E means electrons. And the N means what? Neutron. Now, these subatomic particles in an atom, found in an atom, they have their respective charges. You should be aware that protons generally they are positively charged. You should be aware that what? Protons generally they are what? Positively charged, whereby electrons generally they are negatively charged. This Be means like charge. You understand? Plus V means positive charge, minus V means negative charge. Whereby neutron, as a subatomic particle, you should know this. Neutron is neutral. What did I say? Neutron is what? Neutral. You should note that. Neutron is a neutral subatomic what? Particle. Is a neutral subatomic what? Particle. Thank you so much, guys. Thank you so much, guys. I really appreciate others respond, comment down, share the life with your friends. So this subatomic particles we are looking at, they have locations to which they are found inside this atom. Let me give you the location. Let me tell you the location. Now, this thing that is centrally located, it is called nucleus. What did I say? This thing that is centrally located, what's it called? Nucleus. So, since it's an atom, then I call it atomic nucleus. That's the right word. This is an atomic nucleus because this is an atom. Now, you should be nucleus of 2 out of the 3 subatomic particles. So, we have 3, but this nucleus is made up of 2, which are protons and neutrons. The nucleus is made up of 2 out of the 3, which are protons and neutrons. Are you there? Protons and neutrons are found inside the nucleus of an atom. This is an exam question. You can ask you, where is proton and neutron found? You tell them that proton and neutron are found inside the nucleus of an atom. Just relax. All this is as simple. Now, where electrons are found in what we call orbits. Electrons are found in these circles. These circles I'm drawing. All these circles I'm drawing. All these circles I am drawing. That's how it's done. But don't worry, on subsequent topics will explain why all these things are appearing like this. But you should also know that, okay, this one that I'm doing like this, they are regarded to be called electrons. Class, are you following me? But electrons. Alright, guys, ensure you comment down where you're watching from, so you connect with yourselves. Alright. Moving further, guys, what do? We have to just know a few things about these subatomic particles. Now, you should be aware here that proton was discovered by a man called Lord Ernest Rutherford. Please, if you don't know this before, know it from today. Proton as a subatomic particle was discovered by a scientist called Lord Ernest Rutherford. Whereby electron as a subatomic particle was discovered by a man called J. Thomson. That's the man, Thomson. That's the man that discovered what? Electron. Where neutron was discovered by a man called James Chadwick. James Chadwick. So this is the man that discovered what? Neutrons. Are you there? So note this as well for your exam sake. Note this as well for your exam sake. Alright. So guys, moving further, what do we do? Guys, ensure you like, don't just watch without liking, ensure you like the video. So that is for that. So this is one way we can describe an atom. There's another way we can also describe an atom, and that's what I'm about writing next. There's another way we can describe an atom, and that's what I'm about writing next. So guys, I want to wipe what I just wrote now, like who described these guys, and draw the other way an atom can be represented. I tell you, and because that one is very, very relevant to what we'll be doing today. That one is very, very important to what we'll be doing today. So now, I'm wiping, then look at everybody. This is another way we can represent an atom. We can represent an atom by drawing arcs, which are seen here. Here is represented as A, whereby down here is represented as Z. Are you guys following me? Just relax, I will explain. Relax, I will explain. This is an atom. This A and Z, they mean something. Now here, A has a name. A means something, which is very relevant today. Now A simply means, A has various names, and I'll give you the 3 names for A. A is simply this. Atomic mass. What did I call A first? A can be called atomic mass. If you don't call A atomic mass, then you can call A mass number. You can call A what? Mass number. If you don't call A mass number, then you can call A nucleon number. Please, though, if you observe, I did not say A is called neutron number. I said nucleon number. You guys follow me? Nucleon, not neutron. So these are the possible names for what? A. Now, guys, moving further. What's the name for Z? What does this Z means? Z has various names too, whereby the names include atomic number. Please, oh, there's no atomic number here. Oh. This is the only atomic number, Z. And then, if you don't call it atomic number, then you call it proton number. You call it what? Proton number. So, these are the possible names for Z. A has its name, 3 names. Z has its own name, 2 names. You can call Z either atomic number or proton number. So you can see different ways we can represent an atom. We can represent an atom like this, or represent an atom by drawing an atom. Do you guys understand? Because this one now will help us in this topic. Will help us understand this topic properly. So you guys should listen very well and ensure you like, share the video with your friends. Alright, so guys, moving further, what do we do next? I'm about wiping this part of the board. Guys, let's get to 100 persons in attendance. That means you have to share the live with your friends. Share the lives with your friends. Take the link of the live and share it with your friends. Do that right away, because what I'm about explaining now is very, very key. So now, listen. What is isotopy? It is a phenomenon whereby atoms of same element. Now, everyone listen. Listen, this is O. And this is another O. This thing I'm saying now, this O is a very vital element in chemistry. And what element do you think is represented as O? Tell me in the comment section. What element is represented as O in chemistry? Tell me, guys. Tell me the element that is represented as O. Let me know. What element is represented as O, guys? What element is represented as O? Tell me. Very good. Oxygen. Oxygen is represented what? O. Very good. So now, looking at what I'm drawing now, isotopy is a phenomenon where atoms. So not just one atom, 2 atoms, 3 atoms, multiple atoms. So if to be called atoms, you'll be made up of like 2 and more than. You understand what I mean now? 2 or more than. Now listen. Now, looking at these 2 guys, are they existing in their atomic state or molecular state? Are they atoms or they are molecules? Tell me in the comment section, because I've explained this already. These 2 guys, these 2 oxygen we are seeing, are they structured as atoms here, or they are structured here? Tell me. Just comment atom or molecule in the comment section. That's how I know if you understand. If it's atom or if these two guys are atoms or molecule. Let me know in the comments, guys. Oh my God. No, comment correctly. These two guys. No, I'm not saying you should combine them. Just tell me individually, are both of them atoms? Is this one an atom? Is this one an atom? Or is this one a molecule looking at like this? Or a molecule? I've explained already. I told you whenever an element is standing alone without no number attached, that thing is an atom. You understand? So both of them, tell me, if it's an atom or a molecule. Very good. Very good. Very good. All of them, they're in the atomic state. We are good to go. For these two guys to be like this, we have this part, we've passed this part of the definition. You guys said that isotopy is a phenomenon whereby atoms. So first, for you to undergo isotopy, you must be an atom. So whereby atoms of same element. Now, same element, you can see that they are of same element. Oxygen, oxygen. They are what? Same element have same atomic number. They have what? Same atomic number. So what's the atomic number for oxygen? To get atomic number, we have explained that already here. You just to count the elements. That's why you should know the first 20